Given the function p of x equals negative x times the quantity x minus 4 squared times the quantity x plus 5 cubed, answer the following questions. So we have this polynomial here in factored form. We got a negative out in front. We got 1x living out there. We've got 2x's living in here. We got 3x's living in here. Okay. State the zeros and the multiplicity of each. So part one is not so bad. You take a look at each factor and you would say, all right, well, the number that would make negative x become 0 is just 0. Easy peasy. The number that would make x minus 4 0 would be 4, and the number that would make x plus 5 0 would be negative 5. Okay, so those are my three zeros. So my zeros are x equals 0, 4, and negative 5. Now the multiplicity for each, multiplicity, is completely dependent on how many exponents are attached to that factor. Negative x has an invisible exponent of 1, which means the multiplicity is 1. 4 has a multiplicity of 2 because of its exponent, and negative 5 has a multiplicity of 3 because of its exponent. Okay? So there you have it. There's our multiplicity. There are our zeros. Now we can use this information plus a little bit more to answer B. B wants us to find out where P of x is positive. So this is what I need to do. I'm going to draw myself a simple sine graph. I'm going to mark my zeros, which were negative 5, 0, and 4. I need to find out what my zeros are. Check. I need to find out what the multiplicity is. Check. But what I also need to do is find out the behavior of the graph. And the way I do that is I use the fact that I underlined these x's. I underlined a negative x. I underlined two x's here, right? Because there's two x's. It would be x minus 4 and x minus 4. So I'm going to multiply x squared. And I underlined three x's here, so I'm going to multiply x cubed. Now, by underlining and multiplying the leading terms of each factor, I am finding out what type of graph this is. Negative x times x squared times x cubed is negative x to the 6th power. That is an upside down, I guess, is it sextic? I don't know. Looks like that. That's all I know. Now, this is what I also know. Since I know the multiplicity for 4 is 2, it's going to bounce off of 4. So as I start writing this out, as I start drawing this out, okay, it starts from the bottom like Drake does. It's going to go through negative 5 because it has an odd multiplicity. So it's going to go through negative 5. It's going to come back up, maybe do a wobble here and there, but who cares? Go back down and go through 1 because it has a multiplicity of 1. But when it comes up through 4, okay, it's going to bounce off of 4 because of that even multiplicity. Now, somewhere up here or down here, we have more bumps, but that's not my concern right now. If you want me to put a bump there, go ahead. That's not my concern. My concern is where is this positive? And it's positive at one spot, and it's that interval right there, from negative 5 to 0. Now, do we include negative 5 in 0? No, because we only want it to be greater than 0 and not greater than or equal to. So we want the spots that are only greater than the x-axis, only above the x-axis and not touching it. So we will say negative 5 but not including, all the way to 0 but not including, and that's it. Now, if we did include 0, then we would put brackets here, and we would also include 4. But we don't have to do any of that because we only care about when it's above the x-axis and not when it's touching. Now, last but not least, we are going to be asked to write out the end behavior in limit notation. We know what the graph looks like. We know it looks like that, which means we know that as x decreases, my graph goes to negative infinity. So how do we write that out as limit notation? The limit as x approaches negative infinity of p of x is also negative infinity. As my graph goes to the left, it goes down. Similarly, as my graph goes to the right, it also goes down. So we would say the limit as x approaches positive infinity of p of x is also negative infinity. Okay, so that's free response question number 2, all about polynomials, baby.